d75 minus d naught. So the answer is going to be that tau equals d75 minus d naught, let's see what it minus d slope line. Sorry, my handwriting deteriorated. Divided by minus ln of 1 minus 0.75, which is ln of 0.25, ln of 1/4 would be ln 4. Sorry, no, wrong. Okay. Would be ln 4. Do you understand? That would be not d75 minus d naught minus d. Why this guy doesn't have divided by anything? Because ln minus ln of 1 minus 0.632 is 1. The standard slope method doesn't have anything here. You have this equation, because what divides it for 0.632, you get 1. How are we doing? Robert? Yeah.
This is for, you just chose T75 arbitrarily, not the T90, right?
Yeah. The only reason I put T90 in that exam is I want to very clearly see if they took T90 from the slope line. Clear, guys? Do you understand that? Mm-hmm. So, a modified slope method that uses d from the slope line, then it has to use one equation for tau, matching the 4-star equation. Okay?
Yeah. I'm just like, why we're okay with the 63, but we are not okay with
Because, okay, if we do the same work for T63, for T63, we would get tau equals T63 minus d naught minus d slope line divided by minus ln of 1 minus 0.632 to be put a little bit more like this. If you take a calculator and calculate minus ln of 1 minus 0.632, that's 1. That's why this guy is equal to 1. That's why you don't have anything for 0.63. It's the only one that wouldn't have anything. Got it? Is everything okay? Robert Champagne okay? Daniel? All right. Okay. Now, so we have learned 3 methods. We have learned the do not use method, and the only reason I taught it to you is because you'll see it in all the books, and you'll often see it, and I don't want you to ever use it. That's why I gave it this name. We've learned 2 good methods. Slope line or a modified slope line would be fine. And 3-point methods. Yeah.
When are we going to learn his favorite method? Is that coming up after the break?
It's coming up right now. We still have 6 minutes before the break.
Let's get started, Felix.
But we can, in all these cases, we have a whole experimental curve, and we're using only steady state and 2 other points. And we have a lot more information that we're not using. So a method that uses all the information available would be best. And about 2/3 of you are taking, or at least half of you are taking the optimization class, right?
Yeah.
Okay. Time to implement what you have been learning in your optimization class. Also, those of you who took COD with me, we did the very same thing.
Any other notebooks? For the treatment?
As a matter of fact, I gave you some homework about reactor mode. Was it?
And my $10.
But we did a step change in U, and we got an experimental response, let's say. And my model, this is why this experiment. My model will fit something like that. That's model. What we want to have is the model match the experiment as close as possible. By fixing k is delta y over delta u, we match exactly the steady state. So we'll do that no matter what. But we have a lot of experimental data here. And actually, experimental data, instead of being a smooth line, would be specific points. Okay? We can use optimization. In optimization, you have a performance measure, which is a judgment of how well you do. And in this case, what I want to have is the distance between experimental data and model as small as possible. You can use different performance measures. As a matter of fact, different performance measures lead to different tuning methods in some. But one common one that has a mathematical advantage, that it's a method that leads to unique solution no matter what your initial guesses are and so on. So if you don't have the abomination, everything is good, is linear regression. And in linear regression, the performance measure is the sum of errors squared, where EI is YI, this is measurement. Let me put Y measured I minus Y model prediction. So you're minimizing the sum of errors squared. Minimizing the sum of error would be terrible. Why would minimizing the sum of errors be terrible? Positive and negative errors would cancel out, right? So there's not a unique solution. Something that gives you plus 10 with one and minus 10 with the other would still give you 0. As a matter of fact, the outcome would be what? Minus infinity, if you're trying to minimize them. Absolute errors would be fine. You could do minimize the sum of absolute errors. But then it wouldn't be a linear regression problem, if you would lose the advantage of linear regression. And there's a physical reason for error square. Error square says that it's better to have 2 errors of 0.1 than an error of 0.2. I'm better off having several very small errors than some big errors. So if you do squared, 2 errors of 0.1 add up to 0.1. To 0.2. 2 errors of 0.1 add up to 0.2. An error of 0 and an error of 0.2 add up to 0.2. If you do error squared, 2 errors of 0.1 adds to 0.02, while an error of 0 and an error of 0.2 adds up to 0.04, twice as much as the 2 errors of 0.1. So, minimizing error squared squeezes the larger errors, accepting a little bit more smaller. So that's the performance measure. And my error is going to be for each measurement the difference between what the measurement is and what the model will predict at that specific time. Okay? So, I believe Dr. Chavan is teaching a little bit of optimization in design, in economics, part of senior trio. So for some of you in the future. And those of you who are taking Dr. Kopman's class will be really ready for Dr. Chauhan's class. Huh?
Chauhan.
No, that's
He's a new guy.
Okay, you guys pronounce it Chauhan, not Chauhan? Okay, I'm not sure what's the correct pronunciation. I always call him Chauhan. It's Chauhan?
Chauhan? How do you pronounce Narayana?
Narayana, that's it.
Narayana, okay.
Right, John? Narayana.
Nobody knows.
Your advisor's pronunciation is Narayana. Your advisor's pronunciation is Narayana, right?
Yeah.
Okay.
Nobody knows.
Okay. So, and in the multiple you learn the nitty-gritty, etc. But here, we're just going to learn how to use solver to do it. And so we're going to set it up on solver immediately after the break and do it immediately after the break. I do need to grab my laptop.
Break this right now?
Yes, break it right now.